diamond ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and excuse me, and things gonna improve slowly, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom of phrase. So I'm gonna start with the tool that I have, this week. Go to before start from top player.
Was a time when
Alright, brother and sister, we're live again on television camera. So we have a question right here. See, the area bounded by the y equal to e exponential 3x, whereby x is start from 1, 2, 3, mean that area is bounded from x equal to -1 to x equal to 1. So it to rotate about the x-axis. So the area bounded is rotated about x-axis. So they wanted to find the area. So then after that, we have to calculate the area, and then they say area bounded by this exponential e exponential 3x equals 1x1 rotates about x-axis. It's going to rotate about x-axis. So, and then after that we have to calculate also the volume of the solid of revolution. So let me show you something before we get started. So let me show you what that means when they say area bounded or rotated, etc., etc. Okay, let's assume we have a Cartesian plane. So this is a Cartesian plane. And let's say we have a curve, let's say certain curve, let's say quadratic, something like this. So this curve, we want to get the area, because let's say this is a certain curve, which is going to pass a certain y, whatever, quadratic. So we want to get the area started from 1, let's say to 4. So this is the area bounded between the curve and x-axis. You see what I'm saying? So that's what I'm talking about. Or, not all the time we have to bond it with the x-axis. So it means to get this area bounded, we have to say area bounded equal to integral from the first limit to 1 to last limit, and then here you have to take the top function, the function of the top, which is quadratic. Let's assume let's say it's x squared, but it's not right, because x has to pass at the center. So we're going to take the top function, let's say f of x, excuse me. You take the top function minus the lower function, but the lower function are these x y equal to 0, because the top function and the lower function are this line x equal to 0, and then after they say dx. So this can help us to get the area bounded between the from 1 to 4 and in this area. So they're not going to give like that all the time. Sometimes they're going to give something like this. So they say find the area bounded. Okay, now let's say you have another graph. Let's say this graph is straight line, whereby y equal to 4. You see, so I'm going to say my area bounded, let's say from 2 to 6. So I'm going to say area bounded equals start from 2 to 6, upper graph. So you take my f of x minus lower graph, which equal to y equal to 4. So y equals 4, and then dx. And that's how you're going to get the area bounded between the curve. But sometimes they might give you something like this. Like I said, they might give you however they want. It depends on the equation, how it's given. Okay, so I'm going to give you, okay, you have a Cartesian plane. In this Cartesian plane, you have, let's say, e power 3x. E power 3x, if I put, let's say, and remember, the area has to be bounded, or, let's say, x equal to 0. Means it's going to be e power 0, because you want to draw the graph. E power 0 equal to 1, means this graph is going to cut at 1. Now, let's say x equal to 1. If it's x equal to 1, it's going to be e power 1. But e power 1, remember, when you plug in the calculator, e is 2 point something something. Try to press the yellow button in the case your calculator and get the value of e. E, just go to calculator and then plug in the value of e. They're gonna see e is 2 point. I can remember 2 point something. So say 2 power 1. So it means it's gonna be when x equal to 1, it's gonna be somewhere at 2. Now we plug. When equal to 3, it's gonna be e 3. When equal to 2, power 2. So it's gonna be e power 6. So the value is gonna increase. It's going to increase. So this graph, roughly it could be this way. So this graph is going to come this way, but it's not going to cut at x-axis, because any number you plug in here is not going to give us what? It's not going to give us like look, even if say negative 10, it's going to be e power negative 10, which equal to 1 over e power, and this is going to give us 1 over 2 power point something 10, which is going to be smaller number, but it's not gonna cut out x. It's going to be small value of y, let's say 0. So this graph, if you plug, is going to be here, go all the way. Do you understand what I'm saying? So let's get the area bounded. Let's say start from a half. So our limit start from a half, let's say, and to 8. Let's say this is 8. But let's assume we have another graph. Let's say this graph also is e power x. So it might be something like this, roughly. Also, it's going to pass at 1, excuse me, because, okay. So we want to get the area bounded between the two graphs. Which graph? The e power 3x, let's call this f of x, and g of x is e power x. So the area bounded is going to be here in between. It did not bond with the x-axis between them. So we're going to take the top graph, which equal to e3x minus ex, and then we're going to write our integral, start from a half, lower limit to 80, and then we're going to say dx. So I'm saying that you have to draw your graph in accuracy manner. That was just a rough sketch. So now let's go to the graph. Let's go to the question now given. So in our case, first and foremost, it's always good to draw the sketch. Sketch is very, very important, brother and sister. So now we go. Okay, so now we go. So we're gonna plug in these. Excuse me. Let's draw a rough sketch. I want to say, okay. Draw a rough sketch here now. Sketch. So my sketch is gonna be okay. XY rotation plane. By this graph, we have a x start from -1. So x start from -1 and go all the way to +1. That's what we want to get a graph. But this graph of e power 3x. So e power 3x, look, when x equal to -1, when x equal to -1, it's going to be e power 3 times -1 is going to be -3, which equal to 1 over e. When you reciprocate, it's going to be 3 positive. But when you plug this in the calculator, it's going to give you 0 point small number. So it's going to be here, somewhere here. When equal to 0, it's going to give you 1. Plug equal to 0, it's going to be e power 0 equal to 1. It's going to cut here. When equal to 2, it's going to be somewhere here. Means this graph is going to be like this, rough. Okay, so the area we want the area from -1, means this area here, to 1. So the end is here at 1, area bounded. So this is the graph of y equal to e power 3x. So how I'm gonna, and they say here is bounded by x-axis, mean this area is bounded with the x-axis. We don't have another graph. If we had another graph, then we was gonna go all the way to another. We had to draw another graph, just like I did before. So now to get the area bounded with x-axis, so this is our first function. The second function is y equal to 0, because at x-axis here y equal to 0. So area bounded equal to integral lower limit. So I'm saying this is the formula. Say a b, take the top function. What is the top function for this case? You can say f of x minus lower function, which is u of x, and then this dx. See, so this is the area about which is bounded with the x-axis. Do you understand what I'm saying? So now we go. We say okay, so our area equal to integral. What is our a equal to -1, our b equal to 1, and then we go, what is the top function? Top function is e 3x minus, what is the bottom function? Bottom function is y equal to 0, because they say it's bounded with the x-axis. X-axis y equal to 0, and they say dx. So now the question is finished. What we're going to be dealing with now is just a normal integration. Let's go. So now this time we say equal to integral -1 to 1, and then e power x on u minus 0 is going to be e power 3x dx. So not. So now we deal with the integral. Whenever you integrate exponential, let me show you here. Very, very important this one. When you integrate e, let's say f of x, what you do, you say 1 over, and then you differentiate this right under. So 1 over f derivative, and then write exactly the way how it is, e f of x with plus constant, because you don't have limit. For example, if somebody give me e, and let's say e x squared dx, so what I'm going to do, say 1 over, these are rules, right? So you write the differential of this, which is going to be 2x. So write 1 over 2x, and then you write exactly e power x squared. So they can give anything. Let's say integral and you plus e because there's no constant. Integral of e x 2x minus 1. So what I'm going to do dx is a power. So I'm going to differentiate the power, which is going to give me 1 over. When you differentiate, this is going to be 2. It's going to give a 4x. So it's going to be 4x, and they'll write exactly e 2x squared minus 1. So now let's go back to the question. So we're going to do the same game. Guess what's going to happen there? I'll give a second. Oh, okay. So if we work it out, that one is going to give our area equal to 1 over differentiate 3x. 3x, when you differentiate, you get 3. And then we're going to write exactly e, and then we're going to say 3x. But we're not going to plus c because we have a limit from -1 to 1. So we say -1 to 1 positive. So what we're going to do from here, the question is done. We're going to substitute upper limit minus lower limit. Let's substitute. Right. So we say equal. What is our upper limit is 1. So we're going to say 1 over 3 just there. 1 over 3. Excuse me. And then I'm going to say 1 over 3 just a constant. Or I can just say this is same as e. Okay. 1 over 3, and then we have e. What is upper limit is 1. So we're going to say 1 minus. Now we're going to say now 1 over 3. What is the lower limit? -1. So we're going to say e -1. But we can simplify further. So this same as say e over 3, because e power 1 is e, and then over 3 over 3 minus, and we can reciprocate. This can go to the bottom. So we're going to have a 1 over, because this is negative, it has to go to the bottom, and this power here is negative, is going to become +1. And this our area. But it has to be unit square, because when you find the area, either it could be centimeter square. We did learn in grade 4, 3, 5, 6, and 7. Centimeter square, meter square, kilometer square. Those are units of area. But for now, we don't know whether centimeter or kilometer. That's why I call it unit what? Square or square unit. Either way, unit square or square unit. So finally, if I plug this in a calculator, then it's going to give me. Equal to 6 approximation 66 79 unit square. So this is the area under the curve, which is 6.67. So the area under the curve, is 6.679 unit square. So brother and sister, we're not done yet. We have to calculate the volume of solid revolution. So now let's go for volume of solid revolution. Alright, so for the volume of solid revolution is easy. So this is our curve again. So what we're gonna do is gonna a revolution. You know, like a revolution means there's a rotation. It's rotate. So this stuff is gonna be like a rotate like this. Look, like means it's gonna be rotating. So means if you rotate along x, means x is gonna be our axis. So this graph might come here. Still here. Remember this is 1, so we're gonna pass at -1. You know what I'm saying? Here. Because it rotates. So it's going to be passing like this. Now, see? You see? So now, see? So this graph is going to be rotating like this. I don't know if it makes sense. Like it's rotate like that. So for that case now, we're going to say now, because along x, so this is going to be like our axis, rotate along x. So now we have a set formula also for volume of solid revolution. So volume of solid revolution, is on volume of solid revolution, V equal, so we always say integral A to B, and also same again. But for here you must say pi, because at the end of the day it's something revolution, so it has to be involved with it rotation cycle, pi. So you say pi, and they take upper function square minus lower function square dx. Know what I'm saying? So you take upper function minus lower function, and then right. So now let's plug it in because we got the values. So what is the value here? So we know the value. So we say okay. So our volume equal to integral. We know our a. A is where it starts to rotate. Okay, from -1 all the way -1 to +1, and then pi is a constant. So I can take this pi out, and then I'm gonna have a top function. What is top function? Our top function is e 3x, but this gotta be squared minus. What is our lower function? 0. It's gonna be 0 square and then dx. So what we do now, just like how we did before, let's plug it in, man. So this is equal to volume of the solid revolution, means when it rotates, means this one here. Volume of solid revolution. So now we say this is gonna be 0, and it's gonna be -1 to 1, and this gonna be e, this gonna be 6x, and then we have our our dx. Let me go quick a little bit. So we got dx. So the next step now, we can integrate. So now v equal to, so our pi is still there. We still have a pi. So volume pi is just there. But when you integrate, integral of e power x, we just said on the previous page, is 1 over differentiate 6x, which is going to give you what? 6x going to give you 6. When you differentiate 6x, you're going to get what? 6. And then write exactly your e, which is going to be e 6x, but we're not going to plus c because we have a limit. So we're going to have a limit start from -1 to 1. So next step now, substitute the limit. How we substitute the limit? Upper limit minus lower limit. Upper limit minus lower limit. Let's plug it in. Okay. So what is the upper limit? So we have a pi, just there pi, right? And then let's substitute the upper limit. So our upper limit is gonna be our upper limit. Let's go. Okay, so upper limit, what is the upper limit? Our upper limit is 1. So we're gonna say pi over 6, because this is pi times 1 is pi over 6, and they say e, what is upper limit? 1, and then we minus pi again, because now for the lower limit you substitute again here the first one, and then you minus, now you substitute this one into there. Now say pi over 6 e, and then -1, and now you can just rearrange. This is equal to pi over 6 e, and then minus pi over 6, and then this is has a negative, so I can reciprocate. So it's going to come here at the bottom, 1. So since this is a volume, so it must be unit cubic or cube unit, unit cube, because it's unit. Whenever you have, because it's the volume. Whenever you find the volume, it has to be centimeter cubes, meter cubes, or whatever you got. So for this case here, we don't know whether it could be meter, it could be kilometer, it could be whatever. So we're gonna show them, oh, this then is a cubic meter or unit cube, unit cubic or cubic meter or cubic units. See, and then you can plug that one in your calculator. When you plug in the calculator, as it is, plug in the calculator, we're gonna get a volume in approximation equal to 211.234 unit cubic. So that's how you calculate the volume of the solid revolution. So brother, sister, Kenya Queens, if this is first time on my channel, hit the like button and subscribe and share with a lot of people, man, about this television camera. Peace and love, man. Thanks a lot. So another time again, this is let me just show everybody so that everybody can see clearly. This is Mtwana Wabantu Academy. I'm saying, and the aim or the purpose of this program is everyone should access free, classic, quality education for all. Means the aim